sounds a little important. You wrote a lot about it. Let's go ahead and see what it does. Properties. Not too bad. Here we go. Up on the board, you guys see a graphical representation of an integral of a function f of x between an interval a to b. True? True. Okay. Question. What does the word partition, or if I was partitioning the subinterval, what am I talking about? Splitting it up. Good. I'm partitioning, I'm splitting it up. So if I make one partition, what does that mean?
Two rectangles. Two shapes.
Let's just say this. What if I partition it into two equal pieces, right? And what if I approximate using those two equal pieces? Right, rectangles, trapezoid. Okay. What if I partition into 4 pieces? Better?
Better.
How do I keep on partitioning into to make it better?
8.
Partition into 8 pieces, right? Partition into 16 pieces, right? Partition into what would be next? I don't know if I'm doing equally 32 pieces. After that, 64. After that, 128. After that, 256. After that, 512. After that, 1024. After that, I was using computer numbers, so it was easy. Okay, anyway, I was cheating. What happens as I partition? Our rectangles, the areas are getting closer and closer and closer and closer. They get smaller and smaller and smaller and smaller to my curve, right?
Yeah.
So, if I want to find the actual, we've already kind of talked about it. To find the actual, I need to take the limit as the number of partitions approaches infinity. And then I need to take all those areas of all those rectangles, bases times heights, and it's not going to matter after a while. It's not going to matter if it's from the left or from the right or from the middle or a trapezoid. I don't really care because whatever. If it's getting infinitesimally thin, ooh, that's 2-dimensional. I can accumulate things that have no width in order to find an area. Anyway, there we go. So, hold on, come back. What's the fundamental theorem do? Guys, all of this, let x1, x2, x blah, 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 that's an n minus 1. Guys, what are the x's doing to a, to the interval a to b? They're my partitionings. I have n partitions. If I have n minus 1 hash marks in between, then I'm going to have n partitions, like n subintervals, right? And I want n to approach infinity. Today you're going to see the infinite sum turn into a single subtraction. You're going to see the infinite sum turn into a single subtraction. That's why a lot of people think fundamental theorem of calculus is a pretty elegant proof. I don't prove most things. I think I said this yesterday. I don't prove a lot in this class. Some college professors would hate me. I'm more of an applied person. However, this one I can't not prove. Okay? Here we go. Yesterday we have all these givens. We've partitioned the interval a to b into, I didn't even set a number because we want to approach infinity. Then I have looked at from a to x1, from x1 to x2, from x2 to x3. I have actually established these as 1 subinterval, 2 subintervals, 3 subintervals. I'm going to go up to n subintervals, but still I am trying to eventually get to n approaching infinity. And you guys started to freak out at n equals 10. Okay? Whose lengths we denote? Delta x. All right. Here's where the proof's starting to go. By hypothesis, I'm given some function f of x who is a derivative of, what's capital F stand for? Antiderivative. So f of x has an antiderivative of capital F because capital F prime equals f. Now, if f of x has an antiderivative, that means that antiderivative was able to be derived differentiable, continuous. If it's differentiable, then it's continuous. If it's both, MVT applies. If MVT applies, MVT, normal MVT. If MVT applies, then, what can I say? On, now I'm just going to pick, wait a minute, how many subintervals am I theoretically trying to get to? An infinite, so I'm not going to say all of them. I'm going to pick one, and I'm going to pick the first one, okay? I can say, by MVT, since my function, my integrand, is coming from a continuous differentiable function, I can say on, like just for instance, that first subinterval. On that interval, there must exist. The hypothesis is met, therefore the conclusion is true. Therefore, let me zoom in. There must exist at least one, I'm just going to say, x equal to. Now guys, in MVT or even Rolle's theorem, what's that special x usually called? What do we call him? C. So there must exist an x equals C sub, I'm just going to say 1. Why? Well, it's the special one in the first subinterval. There must exist at least one x equals C. I think this morning, and I'm going to set C sub 1 just for sake of what we wrote down to be x sub 1 star. All right, there's different ways of saying the special one. Some people put little asterisks. Our theorem calls them C's. Whatever it is, on a certain interval, there must exist a special x such that, what's MVT say? Mean value theorem, average value theorem, average value of a derivative, average. The average rate equals the instantaneous rate. The average rate, what's my subinterval? A2, average rate of a function. Average rate of a function, those of you that missed average velocity last time, average velocity, average rate of position. Anyway, average rate of f of x sub 1 minus f of a all over x sub 1 minus a. Average rate equals instantaneous rate equals f prime of a special one. Now hold on, wait a minute. What is the antiderivative prime? The antiderivative prime is the derivative, and the derivative is the integrand, and the integrand is f. So then I can say, just by a quick substitution, I can say, therefore, f of x sub 1 minus, or this implies, f of x sub 1 minus f of a all over x sub 1 minus a is equal to some special f of x sub 1 star. Now usually this is okay, kind of exciting. However, when my subintervals are getting infinitesimally thin, approaching a 0 width, that was why those monks way back when debated as to whether or not this could actually be true, because they said, how can you accumulate or add together 0 widths to actually make an area? But anyway, MVT helps us get there. If this is true, then here's what I can do. Guys, what do we usually do on the subintervals? We find the subintervals, and then we start making rectangles, right? And we start adding together the rectangles, the bases times the heights. Here's the idea. If I wanted to add together f of, let's just start with the first one. But instead of just doing some random f of x value, instead of just doing the left or the right or the midpoint, I'm going to use the special one. And then instead of using x sub 1 minus x sub a and actually writing that out, I can just say, hey, it's going to be times the delta xy thing, right? The change in x of that first subinterval. Now, wait a minute. That's the same thing as f of x sub 1 star times x sub 1 minus a. And that's the same thing as, I can come over here to MVT and say, wait a minute, there's going to be a special x such that this height times this base is going to equal, I can move this over and say, hey, f of x sub 1 minus f of a. How'd I do it? I said, wait a minute, I'm going to add together a base times a height for that first subinterval. And then I said, oh, well, okay, that base is just x1 minus a. Wait, this looks a whole lot like a piece of MVT when you move him up, and I can, oh. Now I could do this again. I could say, hey, let's go to the second one. What's going to be different this time? I'm going to have now a new x sub star for the second subinterval. I'm going to be going from x sub 2 minus x sub 1. And using MVT, I could say that is f of x sub 2 minus f of x sub 1. Why stop there? I'm on a roll. Why not go to the third one? X sub 3 star times delta x sub 3. I can expand that to be and then MVT allows me to then make the conclusion that that has to equal. Why stop there? We could go ahead and do f of x sub star 4, right? But after a while, even though you're like, okay, she's a little too excited about this. Question, is it practical for me to keep going? Why not? What did I tell you about n? We're trying to make those partitions infinitesimally small. To make them infinitesimally small, I'm having n approach infinity, and holy cow, I'm not going to infinity. Thank goodness. But wait a minute, I am. Why? Well, I'm not yet. Love dots. Okay? A super elegant mathematical proof. They might be there, they might not. But either way, we get up to f of, if we follow the pattern, we could have f of x sub n minus 1 minus f of x sub n minus 2. I know you're like, what? Hold on. F of, I'm going to be in the n minus 1th subinterval. Wait, that's not exciting. Don't we have to get all the way to the, yep, here we go. Now I'm going to have f of b minus f of x sub n minus 1. I've now gotten to my final nth. Now remember, limits just take what is a finite, what is able to be solved, and then just says, hey, keep pushing it, keep pushing it, keep pushing it. So I got to the nth, and then we're going to say the limit makes that n keep on approaching infinity. I'm going to have x, nope, what's the final x? B. Okay, this represents all the areas of all the partitions, of n partitions, of a general function over a general interval a to b. Now, hold on, wait a minute. Integral says take all of those and do what to them? Take all the individual areas of all the different subintervals, and even though n's approaching infinity, so I have more and more and more and more, what does the integral say to do to all of those? Add them all, accumulate them all. So therefore, add them all, yay, plus. Wait, what's the really cool mathematical symbol that does repeated addition for us? Summation. So instead of like writing all of that, let's say, sweet. The summation from k equals 1 to n of f of x sub k star times delta x. That looks awful similar to something. And I can go ahead and put in right now, because I didn't say how many there had to be, right? I just said dot, 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 so I'm telling the world, you know what? We're going to infinity. This is going to keep on getting more extensive, more extensive, more extensive, more extensive, more extensive. We could go through writing all of this, blah, but it's still going to be the sum of bases times heights at special, in particular, x values guaranteed by MVT. Guys, hold on. Here's the amazingness. Ready? Infinite math. You would have to add. But by MVT, instead of having to find all these and add all these, what happens when I add all these? It's going to be this minus this plus this minus this plus this minus this plus this minus this plus dot, 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 this minus this plus this minus this. Does anybody see some overlap? What?
Wait. Whoa, magic.
Infinite math. 1 subtraction. Done. Fundamental theorem of calculus. Infinite math.
So it's pretty fun.
One subtraction. How? Mean value theorem. What? Yes. How does that apply? Forever card number? Just kidding. Just kidding. But come on, it's pretty cool, right? No, not cool. Never mind. Don't take proofs in college. All right, so it's okay. It was right about the proofs class where I was like, and applied math. Bye. That was me. I'm not beautiful mind. Not even close. Okay. You get to write down this.
Yes.
But come on. Come on. Pretty cool. Someone? Anyone?
Good job.
I thought it was pretty cool. Here we go. Fundamental theorem of calculus. There's one or two of you. This morning it was Elijah Kim, and he was like, wait a minute. So, fundamental theorem of calculus. Math to be elegant.
I'm gonna guess this is forever card.
Fundamental theorem of calculus. FTC, as we affectionately will call it. Like MBT and EBT and IBT and rolls. Anyway. The fundamental theorem of calculus. Wait a minute, what does capital F stand for again? Yeah, maybe we should remind ourselves, even though it was just like the forever card previous. Antiderivative of the integrand f of x. Just in case you need the reminder. If a function f is continuous on, that's an on, not an or, on a closed interval a to b, then I can make the following conclusion. To find the integral from a to b, now is my start. Well, what if it's not continuous? Or what if there's a vertical asymptote in between? Or what if you're going from a to infinity? Ooh, that's calculus too. Anyway, come back. To find the definite integral, I find the antiderivative. That's what we did yesterday, and the day before that, and the day before that. Find the antiderivative, plug in the top bound, plug in the bottom bound, subtract. Area. So, once you guys finish writing, example, number, first of many, 1. Which is problem number 14 in your book. How do I apply all this amazingness? By partitioning a subinterval into all these different ones and then taking the limit as n goes to infinity of the Riemann sum? No. By saying, who is your antiderivative?
Forever number.
Forever. Number. 30, 34, 35? 35, right? 35.
30 plus C.
Where does Z come from?
Oh, no, C.
Oh, thought we were going third dimension. That'd be exciting. That's more like Calc 3.
There you go.
Jimmy.
What?
You have a closed interval at first and then the little asterisk you go
Good question. Hold on.
Oh, I see.
It has to be continuous on the closed interval because if there is a vertical asymptote at A, the function itself is going to be, if you just think about it, increasing or decreasing without bounds. If you're trying to find area that's forever going up or down. That's why it has to be continuous at A and at B. It's not enough just to be continuous up to there but not including. And then the change in the antiderivative from, you know what, I think that's something I probably wrote in myself. Hold on. See if there has to be a reason why there has to be parentheses. Are you guys finding the antiderivative of number 14 if you're not really interested in the question? Go. It's x to the negative 3 halves. See if I'm right. Not the antiderivative, the function before you take the antiderivative. Jimmy, I'm going to change it. You're right, it should be closed interval. Thanks, Jimmy. You guys make it closed, or you can just say from x equals a to x equals b. I think what I was trying to avoid was from a to a wouldn't be, no, that'd still be a 0. That'd still be fine. Why is it x to the negative 3 halves? Thanks, Jimmy. Why is it x to the negative 3 halves? Because it's x to the 1 and x to the 1 half and x to the 1 and x to the 1/2, I do 1 plus a half, which is 2 over 2, plus 1 over 2, which is 3 over 2, but it's in the bottom, so it's x to the negative 3 over 2, right? But I still have to find my antiderivative. So how do I find my antiderivative?
Well, it's a power rule.
I'm going to zoom in. I'm going to show you a technique because I don't want a lot of you guys skipping steps, because when you skip steps, accidents happen, right? At least they're more likely. I want you to find the antiderivative, which is going to be x to the what? Negative 1/2. 3/2 plus 2 over 2. Don't say plus 1, you'll get confused. Plus 2 over 2, negative 1/2. Divided by negative 1/2 is times the reciprocal, negative 2 over 1. Plus c if you really want to write it. But wait, we have to do the whole plug it thing, so I'm going to say from a to b, we're going to go there. The integral's gone. Why? We took it, right? Limits were allowed to. Remember, limit as whatever goes to whatever. Keep rewriting the limit. Keep rewriting the limit until you do it. Same thing with an integral. Keep rewriting it until you do it. But we still have to say, wait, from a to b. What is my a to b? 1 to 4. Okay. What does the fundamental theorem of calculus tell me to do? Find the antiderivative. Plug in b, plug in a, subtract.
Nice.
Plug in b. What's b? 4.
4. Yeah.
Plug in 4. Wait a minute. Some of you are like, negative 1/2. You gotta be kidding me. I say, psh, you got this, right? Make it easier on yourself if you need to, okay? You can do negative 1/2. Equals. Plug in 4. Plug in 1. Question, did I even need the plus c? Plus c was finding a general antiderivative, right?
Yeah.
But if I'm trying to find a definite integral, a displacement, wait, that's physics, that's section 6-7, come back. If I'm trying to find a definite integral, the plus c is going to have no place because he's just going to cancel out every single time anyway. So then negative 2 over 2 is going to be negative 1. Negative 1 minus a negative 2. Hold on, don't do too much mental math. You scare me when you do.
Wait, hold on. It's not negative.
Negative 2 over positive 2 is negative 1. See what I mean? Minus a negative, okay, maybe you can make that into a plus. 2 equals, hold on, calculator's out. Throw this integral in your calculator. Right, go. Come on. Prove it to yourself and to me that you can do integrals in your calculator. If you want to be super cool, because I haven't showed you this yet, but some of you already know it, you could get out your grapher. Come on, go down. If you guys find an integral, have you yet found an integral in your graph instead of your home window? What? Grapher's out. Prove to yourself and to me that you can actually do this because half the AP, remember, is, hold on, with the calculator. So if they said solve it, you didn't have time to do it you won't have time to do it by hand if it's a calculator portion. If you're super cool, put it in your actual graph. You can do that. Heck to the yes. You can make a cool fraction because we can do that now. You can do 1 over x root x. Oh, come on, you don't need the cool fraction button. Alpha y equals, nd means fraction, hit enter. Alpha y equals, but come on, you don't need that, right? I can graph this puppy and I can say, I'm going to do zoom standard, I have no idea what zoom I'm in. Ooh, there he is. And then, is there this whole menu with cool, like, graphy, mathy things? And is there an integral just waiting for us? Number 7. And does it ask me the lower bound, 1, and the upper bound, 4, and it actually shades it and says, there he is, 1. Anyway.
Wait, you lost me.
My y? It's just 1 divided by. You don't have to do, I did the cool little fraction. You won't graph it? Do zoom standard. Sometimes our zooms get weird. The way that I showed you in class. Type in the function, so I would do divided by x raised such that x goes from 1 to 4 All right, cool kids. Get out of there.
From A to B.
We're done with the calculator because we're trying to do it by hand from A to B first. From A to B first. All right, another one. Calculator's away. We're done. We're done. We're done. Calculator's away. We're done. We're done. Every now and then I throw a little calculator thing in just so that you don't forget you have one, because we are going to use it quite extensively eventually. And even on some, you guys have had some multiple choice or some FRQs where you've used it, right? Gotten some decimal answers. If it was a free response, we should write the equation, what we're solving first, my ones who skip steps. You have to write this and then the answer, even if you use your calculator. Don't just go writing answers all over and put it together in a way that no one can follow your work. But today is not an FRQ day. Here we go. Cool kids, fundamental theorem of calculus tells me to what? Find him by first finding him, not plus C, not plus C. And then plugging in top, plugging in bottom. Guys, I know it's crazy, but where are you going to make most mistakes if you can figure out that green sheet of integration rules? Adding and subtracting. Careful. Careful. What's my antiderivative of 2 cosine x? 2 sine x. Remember, the 2, doesn't he just kind of chill out there? Uh-huh. You could have him chill like all the way out, and you could do like this from 0 to pi. He could be like all the way on the outside. And then you could plug in pi and plug in 0 and then multiply by 2 at the end. Or, this is just for those of you that are like, I need to see everything. Okay, here it is. Or 2 could be included in the 0 to pi. Either way works. Doesn't really matter. Whichever way is going to hopefully have you making fewer mistakes. Just because this one's first, I'm going to go ahead and do him instead. So I have sine of plug in the top, plug in the bottom. Why is there no C? Because it would cancel out anyway. Oh, they're good with that, right? It was an FRQ, if that's a multiple choice. What on earth should you do? No, unit circle. If it's a multiple choice, you gotta match it. You gotta match it. And the answer is 0. Questions? Infinite math and 1 subtraction. Well, after I find the answer derivative. There's the rub. Okay, so keep going. What about him?
Distribute.
Yeah, be amazing. Go. It's all you.
Is that a 0?
Danny, you working with us? Come on, bud.
Oh, I thought you were like Danielle.
You can do x squared. Right, all we did was multiply. So hold on, It could have been a variable, and then you would have variables in your answer, but he's a little 0. I apologize if he was ugly. All right. If you did not rewrite your integral before you integrated, shame on you. That would be major points off. Not kidding. If you rewrite and you have not integrated, he better not disappear. Are we track-a-locking?
Right.
Why is it minus x?
If you don't rewrite your integral We're just trying to make it something we can do, right? If you don't rewrite your integral, what are you going to do? Go plug it in before you ever found the antiderivative. Matthew. Thank you. Nick, got it, plus, got it, thank you. So then I go ahead and 3 over 2, sorry, I thought you said plus, Nick Davis. I thought that was your question. Hold on, I'll come back to you. 3 halves plus 1 plus 2 over 2. That's a shortcut. For a fraction, it's divided by 5 halves, 2/5, nicer, plus x to the 3 halves, divided by 3 halves, times 2/3, plus c, nah, he's going to go away anyway, from 0 to 2. You guys, plug in, keep going. Nick.
So if I went straight from what we started with to the antiderivative,
To the antiderivative, the integral should be gone, but if you just simplify before antiderivative, we're going to have to be doing that because things get more complicated. Well, you went straight to x to the 5 halves, right? What I said is, if you went to x to the 3 halves,
Why is it X entire to
guys, AP number 10 should have front, back, front, back, front, back, front. I don't know, something like that. You're missing something. Better let me know or else you're going to get them all wrong. Every now and then the copier spits out something that's a little disruptive. So you can just attach this to
Oh, talking about this one? Yeah. Oh, is it?
How many of you can do 5 halves in your head? How about 2.5? Is that easier? Right? 2.5? 2.5? I'm just trying to keep us from making silly errors, especially if we don't have a calculator. As long as you can do it, I'm fine, but if you can't, that was confusing. Hopefully that looks better, right? So I end up with 2/5, 2 squared is 4, 4 root 2 plus 2/3, 2 root 2, minus, now I realize some of you can do mental math quite well. That's okay. Just be careful. It's going to bite you in the bum one of these days. Now I plug in 0, 0. I plug in 0, 0. Sweet, 0. If it wasn't 0, this has to distribute to both. Be clear with what you're doing. F of B minus all of F of A. And you end up with, well, what could they do? I don't know. They could factor out stuff, guys. I'm not going to go all crazy into how they could simplify things today, but we know with our derivatives, simplifying sometimes can be the worst part, right? This is one answer, one variation.
Can we get a decimal?
No. Never a decimal unless the problem specifically says calculator. Never a decimal. Because what does the decimals imply? You didn't do it by hand. If you're using your calculator, just plug it in. Don't solve it by hand, right? If you're using your calculator, just be like, ooh, done, right?
Oh, you plug in 0,
Oh no.
Let's go to this one.
Yay.
What does absolute value do to function? Keeps what positive if it's on the outside? Ooh, this is like algebra 2.
The inside.
It keeps the inside, and the inside is a function equal to y, so if it's absolute value of a function, and all the y's stay positive. So wait, if this is the function of e to the x minus 1, who's changing if there are absolute value bars now? Remember these ones, the weird parabolas that turned into w's? Remember these ones? No. Oh, great. Well, there went pre-cal. Okay, so absolute value of an entire function means y equals this. All the y values, if they're negative, they turn positive. If they're positive, they stay the same. The really hard one is absolute value of x, but we're not doing that right now. What do you notice? What is going to change about the integrals when we solve it if we're trying to find the area? What changes between this one and this one?
You don't subtract.
You don't subtract. Well, this area won't be negative, right? Because right now, hold on, guys, remember, if it's area below between the function and the axis, or area above between the function and the axis, where am I going from? I don't even know. Negative 1 to 1. He would be a negative, he would be a positive. They would take away from each other, but wait. What's the absolute value going to do? He's positive. He's positive. That's a drastically different answer, right? Question, where is the point at which all of this change, on one side it's happening, on one side it's not? What's special about the point in between? It's the 0 of the function. We're going to totally talk about, we're probably not going to get to it fully until tomorrow, how to handle integration or integrals with absolute value when you're doing it by hand. If you're doing it in your calculator, there are absolute value bars in your calculator, right? But if you're doing it by hand, you would have to say the 0 of the function, e to the x minus 1 equals 0 at x equals 0. We see it, we'll cheat. But ln of 1 is 0. I'm going to have to split up my integral and say, you know what, on one side of that 0, he might be staying the same or he might be changing. Here's the deal. I don't want to make you graph it every time. So what we're going to do is we're going to do a shortcut and say, you know what, let's go on one side from bound to 0. Let's go on the other side from 0 to bound. And let's just say whatever the area is, well, he better be a positive. And whatever the area is, well, he better be a positive. We're going to write down steps to it. Ooh, maybe today, because we have a whole 90 seconds. It's a good day. Hey, everyone counts, right? For right now, I'm just going to say dot, 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 dot. We'll come back to him tomorrow. Leave me 2 lines. Leave me 3. How to handle integration with absolute value functions. We'll have another example tomorrow. Tomorrow, is it important? Yes. Not only because of the senior breakfast starting at 7, out short, but because we are going to keep going with integration. Guys, it's getting exciting. Don't want to miss a second of it. Write down how to handle integration with absolute value functions. Split up that integral. Split up that integral. Here's a hint. It might have 1 0, it might have 2, it might have 3, it might have 4. However many I have in that interval, I need to split it up. I'm going to assume there's only 1. And if there's only 1, I can use my cool property of integral from a to b can be a to c and c to b. I just need to make sure all the areas will be positive. Cool, kids? If you're working on your homework, if you're working on your AP number 10, I would say homework first. Practice what we taught today so that it doesn't leave your brain. Antiderivative floating, stop floating the bottom, minus. I'll see you tomorrow, if not earlier.
See, I thought super.